Actually, I could have finished.
I could have finished my slides even with this. I think I could finish. What's the word bucket? You want people to scan this? Or no?
Okay, they can scan afterwards, but the next
Nice
slide.
book.
Nice
book.
Okay, cool. Hey guys, thanks for being here. My name is Elias. I work at Kakarot. Yeah. And today we're going to talk about okay. We're going to talk about prove more this. I would say get a mental model around why we prove, why we always say ZK this, ZK that, and try to prove computation. But why does it actually matter? So my point is just to say, why do we actually do what we do? The first slide to get everyone in agreement is blockchains are cool because they are unstoppable world computer, at least Ethereum. This is, I think, one of the most important things when it comes to Ethereum. It's an unstoppable, censorship-resistant world computer. And so it's neutral, it's composable, and it's verifiable. What does it mean, verifiable? As Starknet said, it means that literally almost anyone, could decide to become a participant in the network and verify that every single computation was done with integrity. This is quite nice for a system that is international and that does not see borders. And the problem with centralized systems is they're siloed. So when you want to interact with APIs of payments, for example, you have lots of friction to go through. So if I want my app to interact with maybe PayPal, Stripe, of many countries such as Korea, China, I don't think anyone knows really how to do it. So the friction is really better with these world computers. But then they're slow. So how did we actually move away from authority? We did by having verifiability through re-execution. So I think this is the basis of all mental model when it comes to blockchain. Every single operations that you do, so Starknet mentioned 1 million validators, it means that theoretically it's a bit less in practice, but every time you send one transaction, you should expect it to be re-executed 1 million times, which this redundancy creates a lot of problems on speed. And this is where kind of ZK comes in for Ethereum 3.0. And it's the biggest migration when if we want decentralized systems to also be blazingly fast as centralized systems such as Visa, Nasdaq, or even when it comes to non-payment apps such as gaming. This is Justin Drake from the EF saying that ZK is going to be Ethereum 3.0. So you are in the right place at the right time. 2025 is the year of ZK. And why does it actually matter? It means that you can actually achieve decentralization with speed. And this is this whole idea of scaling. You keep openness, you keep verifiability, but you actually get speed. And you might even get the same speed as Web2 processes. Why? I think ZK has become this black box that people kind of throw around. And I will try to steal parts of presentations that I heard from Dono from L2Bit into explaining why ZK achieves speed. This is a Sudoku. If I ask you to fill this Sudoku right now, it will take you some time. But maybe you don't want to fill this Sudoku, you just want this Sudoku to be filled and you want to be sure it was done correctly. Well, if I give you this Sudoku already filled, it will take you almost like logarithmic time that it would have taken you to fill it to actually verify that it is done with integrity. You just take every line and you check that there are the numbers from 1 to 9 in this Sudoku. So you can apply exactly the same idea. I don't know if this is clear, but you can apply the exact same idea to a rollup, okay? You are going to say that a block, or at least a set of thousands of transactions, is actually a Sudoku to fill. And you're going to trust a prover to fill the Sudoku for you. And you're going to check that the Sudoku is done with integrity on the layer that has the trust. And that layer is your base layer, and in our case, it's Ethereum layer 1. So you're going to delegate something that is very hard to do, fill a million lines Sudoku to a rollup, and you're going to just check that it was done with integrity on the layer that has the most stake. So in Ethereum, you have your million validators and $430 billion of market cap, and there's 30% of ETH stake, so that's 30% of 430 billion. This is enough security in terms of economic incentives, at least for people who are involved in the rollups. All right, so what's a VM? What's an EVM? Why am I speaking about this? Because Kakarot is actually a ZK EVM written in Cairo. Maybe we should have started by this. So EVM is a computation engine that executes smart contracts on Ethereum or any chains that is Ethereum compatible. And on Starknet, you have the Cairo VM. On Eclipse, you have the Solana VM. On Solana, you have the Solana VM. On Move, Aptos 3, you have the Move VM. On Fuel, you have the Sway VM. Why does it matter? It matters depending on who you talk to and what you want to do. If you are a rollup and you're selling block space or maybe mindshare for devs, you are offering to them an abstraction to write apps in. If you are the App Store in an iPhone, you are giving to devs tools such as Swift or I don't know, Flutter, React Native to write their apps. If you're a blockchain, you're selling a platform for people to build businesses and startups or even protocols like governments, but you're offering to them an abstraction layer for them to write apps. EVM is such one case, and it has approximately 95% of the mindshare. So, yeah, in this diagram, I just show you that EVM is just some kind of abstraction that's going to take your transaction in the block and compute them, and then derive a new state of the world. So if blockchain is a ledger, you can send programmable, like expressive transactions that are going to alter the state of everyone's balances, state, NFTs, and so on and so forth. So that's a ZK EVM. It's just an EVM that is able to generate ZKPs of its execution. Why does it matter? For scalability. And so the EVM facts. The EVM is one of the VMs that have a lot of mindshare. So as we are seeing a transition to more modern VMs such as Cairo, we're still facing the facts. And the facts are there are hundreds of millions of blocks being produced every year that are EVM, like targeting the EVM. We need to ZK proof them. This is my claim. You may disagree, but 99% of the blocks being produced, no, this is not true, sorry. But there are many blocks per rollups, and most of them are EVM, sorry, and most of them are not proven yet. So there are, I think, 100 rollups in production today, and 95 of them are EVM. So this is, I come back to this, but you really have to think this integrity web, which was coined by Elie Ben-Sasson, the CEO of Starkware. This integrity web is allowed via ZK. And does it matter that we can do a million transactions per second, like 1,000 on Starknet, maybe more on EVM chains? I stole my own slides from a different presentation to tell you that it matters, because NASDAQ does 38 million daily trades. Futures are like 100 billion per year. Payments, you also get a lot of transactions. So if you are bullish on payments for blockchain, which I believe is like the first use case, the second being big gaming and entertainment, which I'm also bullish about, you actually need billions of transactions being proven every year. Okay, so how to prove the EVM? Cairo. And this is actually interesting because Starknet mentioned Cairo as a smart contract language. For us, and we are among the not so many teams that do it, we're very, very, very bullish on Cairo and Starkware and Starknet, but we actually use Cairo as an infra language, as a systems programming language, and not as a smart contract language. Why? Because it all depends on who you are and who you're speaking to and what you want to achieve. So if you are a roll-up, you're speaking to maybe builders, founders, and institutions, and you're trying to sell block space. If you are Kakarot, you're trying to sell ZK proofs of block space that is EVM compatible. And then, why does it matter? Because, as Starknet said, Cairo is a provable language. Whatever you write in Cairo is provable. So either you write smart contracts, they become provable, they inherit scalability natively. This is good if you're a dev and you want 1,000 TPS and you want your users to have very low costs. What else can you prove? Well, you can prove systems, you can prove infrastructure. So if I write a light client in Cairo, I will be able to create proofs, like a full node in Cairo. I will be able to create proofs of all the runs I do. This is very useful for bridges, this is useful for rollups, and so on and so forth. So it really depends who you are, what you want to achieve. And this is the world if blockchain infra was built with Cairo. You would have all the infra of blockchain scaling natively to immense heights, and you would basically reduce costs of chains by 1 or 2 or 3 or 5 orders of magnitude. So what's the EVM ZK proving landscape? I think this is just to put things in perspective. There are many players in the EVM proving landscape. There are one type of players which are ZK rollups. So in people's minds, ZK EVMs means rollup. It is because historically people who have written ZK EVMs were rollup operators. This is changing today, but you can see that Polygon, ZK EVM, Linear, Scroll, etc. have written circuits that allow to prove the EVM, like the Ethereum state transition function. So these people have ZK proven the Ethereum execution layer, I would say, in some sense. The other players coming in, like Succinct, ReZero, these people are more specialized in proving services. They have written a ZK VM, and they are selling proofs to devs and builders. And then there's Kakarot, leveraging the, I would say, state-of-the-art ZK tool suite from Starkware to also prove the Ethereum protocol. And why this slide? What is the mental model? When you write ZK infra, there is a tension that we have gone beyond. The initial tension was the lower level you write your code in, the more performant it will be. That was the former belief. So if you would write circuits as a builder of infra, you would get speed, but you would suffer from writing very low level. This is not true anymore. And now the consensus of the ecosystem is to move towards ZK VMs that allow you to write provable software, but in a high-level language, such as Cairo, and now Rust. So now that we've kind of beaten the circuits versus ZK VM, which was a 2023-2022 debate, we are going into which ZK VM to pick. And what's so interesting in crypto is that when Cairo was in production 4 years ago, there was only Cairo that was in production. Today, there are more than 10 teams building ZK VMs. So we see that the market moves very fast and everyone is very competitive. I would say the main contenders now today are people who are trying to allow anyone to prove Rust or like Golang or very simple languages that don't have anything to do with ZK, versus people who have built a DSL that is somewhat easy to use, but is still DSL. So in that, I think ReZero, Succinct are on one side and Cairo is on the other. And our argument, our claim, is to say Cairo is just performant enough to be the best, but also just easy enough so that your code bases are very slim and very lean and very maintainable and very secure. So we believe that this is our sweet spot and silver bullet. And 2025 is going to be the year where we go in the arena and prove it. And a bit of history, because Kakarot started 2 years ago, actually as a Starkware R&D project. So the idea was, can we build? It was truly a research project, and the only thing that drove it was a question. Can you build an EVM instruction set in Cairo? Which was a bit weird. If you think about it, it's almost like Inception. You have to build an EVM inside the Cairo VM, which sounds weird. So you're building a VM inside a VM. It turns out it's not weird, and it's what 90% of the market is doing. It's just that I didn't realize it was the best idea then. But Shahar and Vitalik did, so we did it. So when we joined, there was this idea that we were going to build a ZK EVM in Cairo. And then what were we going to do with it? There was really two paths. One is you take this EVM in Cairo, you deploy it as a smart contract on Starknet, and you make Starknet EVM compatible. This is what we did, and we deployed a smart contract that was an EVM interpreter on Starknet in 2024. So this was more a EVM as an interrupt tool, and it went well. We paused the deployment on Starknet mainnet because having an EVM emulator on Starknet is very computationally heavy, and as such, it makes sense to delay it until Starknet can. It makes sense to delay it until there is no risk to congest Starknet on the computation side. And then the second, so that's like the little green milestone that we've accomplished last month. And then the second objective of 2025 is proving the Ethereum protocol. So this is more the best mental model to have on it, I think, so far for me, is to say off-chain, on-chain. So you can have an EVM on-chain on Starknet, and you can have an EVM off-chain that just takes as input L1 blocks and outputs a proof. You have to think about it as a very, very simple service that takes as input a block that is non-proven and outputs a ZK proof of that block. And you have to convince yourself that this is really good, because soon in Ethereum L1, you are going to be able to, at every block, instead of having all the validator set and all the full node set, re-execute the block, you are going to allow them to just verify a proof of the block. And this is exactly the roadmap of Ethereum. This is the roadmap that you can find Vitalik writing articles on this 2 years ago of native ZK EVMs. And you would save a ton of compute by doing this. And you would propose Cairo as the best language to write the infrastructure of tomorrow, which is very bullish, because Starknet is going to make Cairo the most prominent smart contract language, and then you're also going to find Cairo in the infra, which is 2 layers that are speaking to 2 different kinds of people, which I think is very bullish. So what does it look like? You have your computation engine, the EVM, is supposed to compute blocks on transactions, and then you just send your block to the proving engine. It uses a Stark prover by Starkware, and it outputs a Stark, which you can verify on L1, on alt L1s, on wallets, on aggregation layer. Yeah, and as I said, your Ethereum 3.0 is ZK. As you can see, this is the roadmap from a Vitalik article, I think 2 years ago. But you can see that Snark for L1 EVM, fully Snark Ethereum, move to quantum safe, Starks. So we are in the year of the tipping point of getting into the end game. And the thing it looks like is just every single full node is going to run a prover, or is going to rely on a prover. Block proposer, every single block proposer is going to rely on a prover. How are we going to make this palpable? There's a new website from the EF called ethproof.org, and every 100 blocks, the EF is going to send us a proof job to us, succinct and re0, and we are going to have to prove it as fast as possible to prove that we are the best. So check it out in a few months. Hopefully we're the best, or I will never come back to Brussels. I'm kidding. What are the exciting things we can do in the future? I talked a lot, thank you for listening, about the execution layer, which is the part of the Ethereum protocol where you send transactions and they're mined. There is also another part of the Ethereum protocol, which is the consensus layer, which is where attesters are going to watch transactions and sign. The stakers are going to attest that the integrity of the network is safeguarded. And this is going to change very soon. There are research from the EF called the Beam chain, which is the new kind of a new specification for the consensus layer of Ethereum protocol that heavily relies on Starks. And we're very excited to kind of begin this moonshot, or I would rather call it a long-term bet, that Cairo is the best language to write this consensus client. So expect kind of Kakarot to infuse into the execution layer, but as well the consensus layer as soon as possible. And at the end of the day, is really the North Star that you can see from 2022, which really holds in one line or two, which is prove Ethereum. So Kakarot is not a rollup, it's not a network, it's not even a platform. It's a ZK EVM, and if you kind of go back, it's always hard to do semantics fights, but if you go back in 2022, ZK EVM back then just meant a provable EVM, but because it only happened that people wrote ZK EVMs as rollup operators, we ambiguously equated ZK EVM to ZK rollup. But now that we are seeing more separations of concerns between teams that are doing proving and teams that are doing rollups, we're able to finally say it makes sense to become just a ZK EVM. So someone who is building with Cairo, Starks, to scale the Ethereum protocol. Big year ahead. Thank you. questions.
Go ahead.
Is it still in the roadmap then to have this interoperability layer on Starknet? That's
Yes, I mean it's paused right now simply because the emulation of the EVM, as I said, on Starknet is heavy. As soon as it's not heavy and it brings value to the Starknet network to be able to interact with like Solidity smart contract or EVM wallets, we'll deploy it. There was actually an opportunity to us to halt EVM emulator and focus on EVM wallets. We just paused it because it was not really aligned with the proving arbitrary Ethereum blocks. There are some things that are bullish in the next 6 months. The first one is Cairo native, which is an initiative from Starkwire Lambda class to compile Cairo code to MLIR and then execute it natively, which will speed up the execution on Starknet, maybe enough such that Kakarot compute doesn't congest the Starknet ecosystem. The second one is 2, which is the second generation of Stark Prover from Starkware. And with 2, you should be able to support very heavy compute. The overhead is between, depending on transactions, it's between 10x and 100x. So you have to think, in the worst case scenario, you get single digit TPS on Starknet. And so from this, we thought, okay, let's put a break on this and focus on something that we're very, very excited about, which is Proof Ethereum protocol. But what's really fun is our code base is complete. It has been audited twice. It has been running on Starknet Sepolia for 6 months, and it has processed over 1.6 million transactions, EVM transactions on Starknet Sepolia, and has had 50,000 unique wallets, EVM wallets. So on that side, we're ready. And we're also excited to collab with all the roll-up as a service providers in the Starknet ecosystem to deploy EVM Starknet app chains that rely on both EVM engine but also the Stark ecosystem, which we think is very exciting to kind of push the boundaries of what it looks like to have a really cool EVM and Starknet app chain in the coming months. So I think Kakarot is just still supposed to coexist with Starknet, Starkware, and be I always call it the EVM team, or like the EVM arm of Cairo. This is how I see it.
So which use cases do we unlock by improving Ethereum? Why do we want to do this?
So you may unlock the ability to run a fully verifying node, fully validating node in your smartwatch, your phone, your browser. Currently, when you run, for example, MetaMask on your phone, you are relying on what is called the RPC endpoint, for example, Infura endpoint for MetaMask. And it is actually a point of trust at which, because every data that you receive from this RPC, this URL that feeds you data about the blockchain is trusted. So of course you trust MetaMask because it is, of course, first of all, this is not obvious, but you trust MetaMask. And if you don't, you might want to engage resources to run a full node. But this would enable more sovereignty, such that you would never have points of trust in consumer apps. So that would be bullish. Another bullish thing is just lowering costs all around. What you can do when you lower costs, you can bump all the characteristics. So the idea would be to have tens of thousands of TPS on most EVM networks. What else would you get? You would get fast finality and easier bridging, I would think. If you can prove, this is not entirely true, but if you can prove the state transition and the consensus of your chain very fast, you can settle this proof on an Alt L1 and bridge funds. Although you can already do it with a sync committee, but I think the sync committee is regarded as something not so perfect. Quantum safe. But I think it's really this idea that if you have fully Starkified Ethereum L1, but also L2s, you really get 1 million TPS. at reasonable costs, and you have everyone in the network able to fully verify your chain without trust points, because you only trust the math, hopefully Cairo math.
What would be your advantage compared to risk 0 and succinct?
So I think that's a good question. So Succinct just released their white paper, I think today or yesterday. And their motto, I think, is prove the world software. So because they have written ZK VM that proves RISC-V programs, you are able to prove ROS programs using Succinct and RISC-0. So their mode, or at least their objective, is to prove any arbitrary software. We are taking some kind of a counter stance. We're saying today, we believe that 95% of the market revolves around maybe 4 or 5 pieces of software. The execution layer from the Ethereum protocol, the consensus layer, a few bridges, and that's it. And when you think about it, you write these things once. So I'm moving away. I don't know if this noise is triggered by my proximity to the. Okay, never mind. So our counterclaim is to say, because you don't write the EVM 10 times a day, it is fine to bear the friction of having to write Cairo. It is overwhelmingly lower to write it is overwhelmingly less hard to write Cairo than it is to write circuits. Proof is Kakarot has been mostly less than 10 people for the past 2 years, and with 0 cryptographers, and we have completed the EVM implementation 3 times. So yeah, there are not that many pieces of software that you need to prove, at least today. It makes sense to write them in Cairo, because by writing them in Cairo, you get between 10x or 100x improvement in speed and efficiency. And so it's this double claim. You don't need to write circuits, you need to write ZK-VM targeting languages, and you don't need to prove everything yet. You just need to prove EVM. And if you just need to prove EVM, you write the implementation in 2 months in Cairo, you audit it once, and you're good to go. The weaknesses? I think the main weakness that, for example, Succinct and RISC-0 are putting forward is you cannot just import Rust code that has been written by the tens of thousands of Rust devs. So today there are maybe 1,000 Cairo devs-ish, and there are orders of magnitude more Rust devs or Solidity devs or otherwise. So the amount of knowledge produced aggregated is lower. That is one weakness. And the second weakness is maybe that it's not such a it's not so mature. It was created less than 2 years ago, and it has breaking changes very often, which might be annoying when you're trying to build boring software that doesn't change. But this is about it. And if you are a startup in crypto, these are the types of things that you kind of accept to move forward and to kind of be first mover on the market. So I would say for us, it's not been a problem. Yeah, and then the problems of Rust for proving is that it's not RISC-V as an instruction set was not made to be proven. So you're getting lots of friction, I would say, in the performance part of it because of the CPU design. I think that's it. And then lots of the parts of the game are being done on what is called precompilers or built-ins or accelerated chips. And so when you're building blockchain programs, you actually find, and this is parts of the reason why ZK VMs without the E are getting better than circuits, is because people have identified that the bottleneck is usually 3 or 4 operations, is very often like maybe hash functions, cryptographic primitives. And so usually what happens is actually the teams, so Starkware or RISC-0 or Succinct will write accelerated chips software just for these operations like HAC, SHA. And
Tu veux qu'on le coupe?
non, je sais pas. Enfin, and so very often there is lots of the game is inside this kind of niche knowledge. Who is the best team to write these accelerated programs? who is the best team to write the circuits, the arithmetizations that no one sees, the AIRs, as they call them, arithmetic intermediary representation, I think. So it seems that a lot of the win conditions lie in who you bet on. And so at least for us, we've bet on Starkware for the past 2 years, and it has been a winning bet. And so when you bet on Starkware, you bet on Cairo, and you bet on the amazing ecosystem that Starknet has, that we kind of see each other and get to know each other over the years. This is bullish. Brother.
Real.
What's your business model going to be like 5 years from now? If we can prove stuff on the smartwatch and so on, where do you?
No, you won't. I don't. Maybe you will be able to prove stuff on smartwatch, but the argument was to say you can verify proofs on smartwatch, and you delegate the hardship of proving to someone who is prepared to do it, whether it is a decentralized proof of network, whether it is a permissionless but still somewhat centralized proof of network or aggregation layer, and so on and so forth. The business model is an interesting question. For now, we believe that you are able to get away with it with a paper proof, because it is the same as paper block space. Like when you say to someone, I want you to pay me for me to include your transaction. Now we're saying, I want you to pay me so I can make your transaction more scalable. This is a claim. It has not been verified just yet. There are many claims going around. One claim is that proofs will be commoditized, so prices will rush to zero and everyone will fail. I don't know. I also don't believe it is true. But I think we are not so far from a Uber or like Lime market where I don't know if you remember in 2020 or maybe before, there were so many brands of scooters or like bikes, and then only 3 remained. I think we are in that type of situation. There's going to be lots of proof system, and at the end we'll only need 4 or 5. So I'm extremely confident that Cairo will be one such example.
Regarding the green milestone that you achieved in 2024, which was EVM on Starknet.
Yeah.
If I understood correctly, the goal was to basically take some bytecode of a deployed contract on Ethereum and like copy paste and make it work on Starknet.
Yeah.
Right. But how do you, there must be lots and lots of issues with this. For example, some codes use other contracts that are at defined addresses, and these addresses would not be the same on Starknet. Like for example, on EVM, maybe I'm Ave and I use another contract which is 0x123, and it's like hard coded in the code. So this means it's in the bytecode, but once I get to Starknet, it doesn't work because it'd be calling 0x123, but this doesn't exist on Starknet. How do you handle that?
So I'm not sure about your exact example about Ave. What maybe you're saying is Kakarot able to, if someone is trying to deploy some Solidity code on Starknet via Kakarot, are we able to have the same address derivation as L1, like with create, create2, and account deployment? Yeah. The answer is yes, because we wrote like registry of addresses that behaved exactly like the Ethereum spec, at least for address derivation. There are 2 reasons for this. One is Ethereum addresses are 20 bytes, and on Starknet it's 32. So we had to make a registry. And the second reason is you don't want to break the spec, especially on Create2, learning from ZK6 problems. So you want Foundry, Hard Hat, all the tools that expect a contract to be deployed at a specific address to do it. So this we had, no problem. And then if someone somehow wrote, hard-coded the address of WETH on L1 in their contract, then they're wrecked on Kakarot, but they're wrecked on Arbitrum and Base. Yeah. So we didn't account for this, but thankfully no one ever came to us and said, guys, there is a hard-coded address in this contract, can you do something? The only one problem we had was, actually funny enough, there was the Arachnid deployer and CreateX, all these kind of factory contracts that people use to get deterministic address deployment. And we did spend a bit of time to handle these. I think it was because it was pre-EIP 155 deployments, which for the deploy of Ethereum, this was before there were other networks than Ethereum, so there wasn't this idea of chain ID. And the thing that would happen is you would sign for a transaction on Ethereum, and then anyone on other networks that were EVM could replay it, so they could rect you, essentially. If I say that I give Scott $100 on Ethereum, and then someone can replay that transaction on 5 networks, I gave him $500, essentially. So there was an AIP that would secure your signatures by making them chain specific, and this was back in the day. So yeah, I mean, Kakarot passed the Ethereum Foundation execution tests at as much as any other EVM chain. So that was kind of our North Star for combat. We didn't have equivalence in the sense that we didn't have blob-based fee, we didn't have a pure gas market, because on Starknet it's first come first serve, and other such examples that are like on the edge, but devs would not have to kind of bear the problems in the best case. Yes.
I don't know, maybe this is not relevant, but we had a presentation by Hile on Friday. They also kind of want to prove everything. I'm pretty sure you could verify Ethereum then on Hile.
Yeah.
I don't know, is there any kind of synergies you guys could have, or how do Kakarot and Hile kind of compare with each
Okay.
other?
So actually, Ile is what they, I don't know if they say coined it, but it's like a lean blockchain. So it's a blockchain, so it's an alt L1. So it would be comparable to Ethereum. And their kind of claim or bet is to say, actually, the only thing that L1 should do is order transactions, but not execute them. Order a transaction and expect a proof to be delivered for that specific transaction. So their L1, you have to think about it as a ordering L1 plus verifier. And Kakarot, if you had to put a hat roll on us, we would be a prover.
Yeah.
So the synergy is Bob wants to do something on their smart contract on Hile. They are posting a transaction. Now that they committed to the transaction, they need to prove it. And so they would knock on our door and say, I have this payload, can you prove it? And then we would run our Cairo program and prove it.
There's also a concern regarding the gas cost of the Stark-based proofs on L1
Yes.
for the settlement.
Yes.
Compared with the other solutions.
So if I remember correctly, verifying a Stark proof on Ethereum L1 costs 5 million gas. Depending on the price of ETH, this can range from $50 to $500. And if gas is expensive, closer to $1,000. A Groth 16 proof, so a Stark is fixed size, it's 500k gas or maybe 50k. So it's overwhelmingly less expensive. I claim that it's not a problem. Why? Because we have such a thing as aggregation layers in the beautiful object of Shark, which doesn't get enough credit in my view. I think it's a jewel of Starknet and Starkware. It is an aggregation layer that is able to recursively prove thousands of blocks into one single proof. What does it mean in practice? It means that you are not paying $1,000 per L1 verification per user. You are sharing this cost among all the people who are in your aggregation layer. So if there are 200,000 blocks, which can happen in an aggregation layer, you're actually doing $1,000 divided by 200,000, which in the end isn't so far from $50. So if you're dividing these $50 by 1,000, you're still linearly going to zero. And I claim that as you have more blocks per second and more users and more chains that participate in your aggregation layer, it is not a concern that your verification is expensive. I would go as far to say it is more a concern to have a trusted setup than to have high prices of verification. And when you see the competition, so AgLayer from Polygon, Elastic Chain from zkSync, everyone has come to the same conclusion, which is you need to aggregate proofs. You need not verify every single proof that you have on L1. You have to imagine it like a tree structure. So you have, at the bottom of the tree, you have one proof per block. You could have something different, but imagine it's one proof per block. You have 2,000 blocks, and then you're going to write a program that takes 2 proofs and verifies that they were done with integrity. And so you are doing 2 to 1, and you have some kind of Merkle tree structure in which at the end you have only one proof. And this proof is like a macro proof that says, I have seen 2,000 blocks. They were all executed with integrity, and this is called the, at least for Starknet, this is called the Starknet OS. No, this is not true. This is called shard. And every single leaf of this tree executes the Starknet OS. I think so. I'm looking at Starknet for validation. I hope I'm not saying things that are wrong.
Yeah, that looks interesting, but it looks slow.
Yeah, it is. Yeah, that's a good point. So for finality, this is slow. So finality today on Starknet is 8 hours. You could go down to, so funnily enough, you have to think about it as kind of a bus that goes when it's full or when it's late. So on Starknet, it goes either every 8 hours or when it's full. What does it mean? It means that actually, if your aggregation layer is extremely popular, so imagine if there wasn't Starknet only, but 20 app chains that have big usage and Starknet, and then a few others use cases, you would fill this bus not in 8 hours, but in like 1 minute. So I agree with you. Aggregation layers have this annoying thing that if they're not popular enough, or they take time to amortize the price of a proof, and then you lose on finality, which is very annoying. 8 hours is a long time. I think in 2025 we'll go down to a few minutes. What's not so bad is that optimistic rollups have 7 days finality, at least for withdrawals. They're trying to get it down by converting to ZK. But it's not an excuse, and it's not even like a sidestep. I really think that for aggregation layers to go to the next level, we need to get them to 1 minute finality. So how you do it, you make the prover faster. So today, a Starknet block takes 20 minutes to prove. So you need to go down to a few seconds, and then you need a lot of usage, such that you amortize this 1,000 blocks across thousands of people. But we are getting there, so that's bullish.
Proving time is a problem.
Sorry?
The proving time itself is a problem. At some point you're not going to get the proving time. Well, you're going to get it lower, but 1 minute.
Yeah, so the proving time to 20 minutes is the Stone prover, which is 5 years old. And the belief, at least the early numbers of Starkware, is that Stu will get a 40x improvement up to a 1000x improvement.
Okay, but just knowing the runtime, for example, of this the Starknet OS right now, I know that for full blocks, like if you have 300 transactions, like 1000 transactions, you're already at 5 minute runtime. Without proving it.
So you're saying even if the prover is 20 seconds, the bottleneck will be executing the Starknet OS?
Yeah, because there you cannot use Cairo native, you have to use Cairo VM.
Yeah.
And so basically you have some bottlenecks there. You can, I mean, it's trimmable. I'm not saying it's impossible, but it's
So you're saying?
It's not like 1 minute finality is still quite far away.
Okay. So 300 transactions, 1 block with the Starknet OS, is it with the Rust VM?
Yeah.
That you, so it's finished. What was it before with the Python Cairo VM?
I got the numbers from Starknet, they say like more than 1 hour.
Okay.
So,
That's bullish. That's already
it's already great.
that's already 20x. Thanks, Winsung Lab.
So now we need to rewrite that in Zig or something faster. I don't know. But,
So maybe what you could do is, I don't know if it was Ilya, but you could also say, we don't believe the minimal brick to be a block. We believe it to be a set of transactions. So you would not be bottlenecked by having 300 transactions to go. You know what I mean? So the recursion tree, you would actually not start at the block, but at every 10 transactions.
yeah, but that's even worse.
Why?
Because you have to recompute the state commitments every time.
And you delay the marketization.
Yeah, but then actually, yeah.
Plus, you should know about it. Doesn't Solana do delayed marketization?
They do snapshots and they do partial, well, they do incremental state commitments.
Would that solve Starknet's problem?
Absolutely not.
Okay, never mind. And how about delayed marketization?
Delayed marketization, I mean, it's already what they do, right? Because you do it only once a block, but it's kind of, it's one operation that you don't want to do too often. So you're gonna delay it. Are you gonna delay it for more than 1 block? I don't know. Maybe that has problems because then you have trouble proving the state of the chain at each block. You only have the checkpoints every few blocks, and that could be a problem for specific applications.
Okay.
So yeah, I don't know exactly. You can tweak it. You can play around with the ID, but at some point you're gonna have to merkleize. You're gonna have to prove that merkleization, and that's costly. And the problem is that running the prover for only 10 transactions as well. How do you prove that you're running these transactions on the correct state is the main question.
Okay.
Yeah, basically, if I can summarize the issue, is that to prove things correctly, you have to prove that you're executing transactions with the correct state. And if you don't have a state commitment that says this is the correct state of the chain at this stage, you cannot do any proof actually.
Okay, so it's the wrong level of abstraction to cut things. But then you could, I think we discussed it with Char, the other one, Samoha, which is continuations, which is you kind of build on the idea that from 0 and 16 that you can break sub parts of a proof, not by breaking down them into smaller transaction chunks, but by breaking the proof itself. I think there are some trade-offs, but it is doable. I think it's not in the roadmap yet, so I think you're right that maybe 5 minutes is the bottleneck, and then for the next 6 months, and then if people think it's still too much, they move to 1 minute.
I mean, get it down to 1 hour already.
Yeah, true. Step by step. The main argument to get it down to like a few minutes is to get layer 2 to layer 2 trustless interop that goes back to L1. And this is a like TBD in terms of if people actually want it very fast, or if they're fine waiting a bit, or if they would rather use an abstraction layer such as hack layer to do interop and not even go through L1 with this idea of pessimistic proof and composing proofs. I think this is a cool rabbit hole to go down. Plus I'm pushing Shark to do pessimistic proofs, so.
Thanks, Elias.
Thank you guys.